Graph Theory, page 21. By now you've probably realized that many applications of graph theory about finding an optimal solution, fastest route, the cheapest price, etc. Spanning trees can be utilized to find optimal solutions as well. A minimal spanning tree for a weighted graph is a spanning tree for that graph that has the smallest possible sum of the weights. To find a minimal spanning tree, Kruskal's algorithm can be used. Kruskal's algorithm is used to find a minimal spanning tree for a connected, weighted graph. So we will choose edges for the spanning tree in the following manner. I'm going to go ahead and move this up. And so we will use these steps to help us with example 21. It says choose the edge with a minimal weight and highlight it. Okay. So as I look at this particular graph, it looks like my edge with the minimal weight is from F to D. Has a weight of 12. It says on step 2, choose the edge with the next lowest weight that has not yet been selected and highlight it. Okay, so it looks like my next lowest weight is from F to A with a weight of 15. 3 says continue choosing edges in the same manner, except do not select any edge that will create a circuit among the highlighted edges. Okay, well, I will follow their advice there. And then my next edge would be 19. And then the next edge would be 24. Okay, the next edge would be 25, but the problem with that is that would make a circuit. And this other one over here has a weight of 25. And that will work for us because that incorporates vertex E, and I have the minimum spanning tree. So let's add all those weights together. 15 plus 19 plus 12 plus 24 plus 25. And my minimum total weight for the spanning tree is 95. Here's a great application where we could use Kruskal's algorithm. It says a botanical garden is putting in 6 new displays and needs to run irrigation pipes to each one. The graph below shows the distance between the display in yards. If they want to install the minimal amount of pipeline, how much pipe will they need? Okay, so let's find the edge with the lowest weight, and I think we're here at 8. And then the next one would be 9. Then the next one would be 11. And the next one would be 12. I believe it's this one. And then it looks like the next one would be 15. Okay, this was a fairly easy example because I did not have to cross out any edges that made circuits or anything like that. So when I add those edges, the weight of those edges together, get 8 plus 9 plus 11 plus 12 plus 15. So it looks like they will need 55 yards of pipe.